Every year in the United States, approximately 45,000 persons lose their lives in traffic accidents. Hundreds of thousands of serious injuries result from these accidents as well. In the 1960s, Ralph Nader's book, which complained of automobiles being unsafe at any speed, made the American public aware of these statistics. In response, government agencies addressed the problem by enacting laws which set safety standards for automobile manufacturers. Yet, even with seat belts, padded panels, safety door locks, and lower speed limits, death and injury due to highway accidents have been reduced only slightly. Meanwhile, repair costs have soared upward each year. Dramatic reductions in highway deaths and injuries will not occur until the industry rethinks its concept of what makes a car safe. Automobile safety centers around the packaging of passengers in a vehicle. Today's safety problems are the result of various defects in framework design. An automobile and its passenger compartment can be compared to an egg. Any impact sufficient to break the shell can injure or kill the passengers inside. During a collision, current automobile construction allows the metal of the frame and body to crush inward on the passenger compartment. The occupants are not adequately packaged to prevent injury or death, even at what may be considered safe speeds. Bill Taylor of Weslaco, Texas, has spent years rethinking the basic construction of the automobile. Recently, Mr. Taylor was granted a patent by the United States Patent Office, which describes the Taylor Safety Vehicle. To understand the construction method patented for the Taylor Safety Vehicle, it will be helpful to understand the construction of a bicycle wheel. By itself, the rim of a bicycle wheel is a rather flimsy object, easily crushed between the hands of a man. However, if a hub with spokes radiating to the rim is added, it becomes a structure that will support the frame of the bike and a couple hundred pounds of rider through bumps, turns, bangs, and stresses without bending. The strength is obtained by converting the flexure load of the outer rim to an increasing stress load on the spokes. The stress accumulates to a maximum on the spokes that are 180 degrees across from the point of flexure load. Although those spokes, which are not 180 degrees across from the maximum flexure point, are not fully loaded, they serve the important function of preventing the outer rim from buckling or bending, thus allowing the rim to retain its shape. Lightweight and strong. The physical laws that apply to the bicycle wheel are the principles behind the Taylor Safety Vehicle. If a vehicle frame were to be constructed utilizing the principle of the bicycle wheel, it would be possible to obtain sufficient strength within the frame itself to resist collapse should collision occur. The first impression to the bicycle wheel comparison may be one of a vehicle with a lot of undesirable wires running throughout its innards. This is not so. The rim hub spoke principle allows for many variations, one of which is used in the Taylor Safety Vehicle. Instead of long spokes connected to a small hub, the Taylor Safety Vehicle utilizes an outer frame connected to a large hub by short cables. Because the principle is the same no matter what the configuration of the rim hub spoke system, the Taylor Safety Vehicle retains its strength without a maze of wires running through the body of the vehicle. It is guesstimated that the Taylor Safety Vehicle would adequately resist collapse at speeds of up to 40 miles per hour. This should reduce damage to the automobile during collision. With the Taylor Safety Vehicle's resistance to collapse, it is necessary to package the passengers to resist a high rate of deceleration. The standard 2-inch seatbelt will not cover an adequate area of the body to offer proper restraint. Seatbelts alone will not safely retain a person during a collision involving non-collapsing vehicles. Therefore, the Taylor Safety Vehicle's occupants must be packaged for safety by innovative design of the passenger compartment. In the Taylor Safety Vehicle, the dashboard is transformed into a panel, which begins in the lap of the passenger and extends upward scroll fashion towards the windshield. A rigid lower portion of this panel turns in as a scroll about 1 inch from the top of the legs in a sitting position and unwinds toward the abdomen, curving outward from the body to the windshield. The windshield is located at a distance from the person sufficient to allow a 6-foot 2-inch individual to be retained by the scroll against his legs and abdomen. On impact, the body lies against the upward incline of the scroll dashboard, the head unable to reach the distance to the windshield. Similar innovations were incorporated into the front seat, offering the rear occupants the same protection. The combination of the rim hub spoke design with the scroll, dash, and seat innovations in the Taylor safety vehicle will greatly reduce damage to vehicles and injury to passengers when collisions occur. The Taylor safety vehicle has other advantages for the motorist as well. With construction based on a rim hub spoke design, the automobile becomes much lighter, resulting in substantially more fuel-efficient cars. It would also be expected that insurance costs would be lowered due to a reduction in passenger deaths and injuries. Repair costs should also be drastically reduced as a result of the impact resistance of the Taylor safety vehicle. Obviously, producing this type of automobile will be a major undertaking. There will be considerable design and styling work to be done before a prototype could be built for testing. However, there is no doubt that the end product will result in the first truly safe vehicle. The Taylor safety vehicle will attract the attention of the press as well as the populace of the world. Those with imaginations will envision the value of the publicity given to the builder of the Taylor safety vehicle by the media. Certainly, a genuine safety vehicle is marketable and would be desired by the buying public. The inventor of the Taylor safety vehicle is William D. Taylor, 1600 South Orange, Weslaco, Texas. Mr. Taylor was granted patent number 4,647,527 for this invention on February 3, 1987. Those desiring more information about the Taylor safety vehicle may contact Mr. Taylor in Weslaco by phoning 512-968-6972.